Hi everyone. So we're going to continue our conversation about compound interest in this lesson, and I started out by putting a list here of what we had observed looking at compound interest in the previous lesson. So we built a chart in which we looked at what happens if we are investing $10,000 at a 12% annual rate compounded monthly. And we looked at the amount at the end of months. We looked at month 1, month 2, and month 3. And then I actually encouraged you on your own time to keep it going for a couple more months to see if you can see the pattern flesh out. So, a couple of quick points, and we're going to reiterate this in a second. The 12% is an annual interest rate. So that's the rate, that's the percentage that you can expect to earn over the course of a full year. However, since we're compounding monthly, we would need to take that annual rate and divide it by 12 to look at the rate that we're earning in each compounding cycle. Now, we went through the process, and you'll remember we kind of dragged it out and we looked at we algebraically simplified. And what we saw is that after 1 month, the amount in the bank account was $10,000 times 1 plus 0.01. The amount after 2 months was 10,000 times 1 plus 0.01 squared. And the amount after 3 months was $10,000 times 1 plus 0.01 cubed. So what I hope is that you maybe did 1 or 2 more months and you were able to see that after n months, no matter how many months had passed, the amount in the account would be 10,000 times 1 plus 0.01 to the power n. So I want to use this as a jumping off point to introduce the compound interest formula. Okay, I want to kind of use what we learned here to summarize it, not just for a $10,000 at 12% interest monthly compounding situation, but for all situations in general. So we're going to talk about the compound interest formula. And to do that, I'm going to introduce a few bits of notation. So A is the actual amount. So you invested this much money, how much is it worth a certain amount of time down the line? So that's A. P is the principal, and that's the initial amount. R is the interest rate, and this is the annual interest rate. N is the number of compounding cycles per year. So, for example, annual compounding would mean that n is 1. Monthly compounding would mean that n is 12. Quarterly compounding would mean that n is 4, and so on, right? So n is the number of compounding cycles per year. And then lastly, T is the time the investment is left to mature. Generally speaking, probably 9 times out of 10, this is going to be in years. But you will probably once in a while encounter a situation where it's given in months, and then you have to be a little bit more careful with your units. So now for the formula. And again, this should not come as a terrible surprise, but we're going to make sure that we'll align it. The compound interest formula is A is equal to, P times 1 plus R over N to the power nt. Okay, so we take the principal amount, we multiply it by 1 plus the rate per compounding cycle, which is what R over N is, and we raise it to the power nt, which is the number of total compounding cycles in the total time the investment is allowed to mature. So this is something that we were seeing in the example that we did, but of course the example there was very low, short term. We were just looking at a couple of months, but you can imagine if from our last lesson, I had asked you the question, okay, what's the value of this investment going to be in 2 years? Well, you would have had to convert, since the pattern that we were starting to establish was in months, you would have had to convert those 2 years into months, and it would have been 24. So that is where that NT comes in, because the fact that we were compounding monthly means that if you're being asked a question about years, you'd have to convert those years into months. Okay, so we're going to have a whole lesson just on examples, but I wanted to just do one token example so that we kind of had a little bit of exposure working with this formula. So, example, say that $5,000 is invested at, let's say, 4% annually. And let's say that it's compounded, we'll start with monthly. How much will there be after, and let's say 5 years. All right, so I'm going to go back to this blue color that I was using before, and I'm just going to label all of the pieces. So A is what we do not know here, right? We're being asked how much will there be, meaning we don't know A. P, that's the initial amount. That's $5,000. R is the annual interest rate, so that's 4%. I'm going to go ahead and write it as a decimal since the percent symbol is good for notation, but it's not actually used in calculations. N is the number of compounding cycles per year, so since we're compounding monthly, N is 12. And then lastly, T, the time that the investment is left to mature, is 5 years. That's given to us here, so T is 5. So since we want A, it ends up just being about evaluation. So we have 1 plus R over N. So check it out. Again, that 4% is an annual rate. So you're not going to see a 4% rate every month. You're going to see 1/12 of that. So that's why we take 0.04 divided by 12. And then we raise that to the power n times t. So again, that's the total number of compounding cycles over the course of the time that we've left the investment to mature. Since there are 5 years and 12 months in a year, there are 60 months total. Okay, so let's see what this comes out to be. So for this, it really is helpful to have a scientific calculator. Your phone does turn into a scientific calculator when you turn it on its side, but it's not super easy to work with. So I highly recommend, if you can afford one of the ones that I use in class, those TI 30Xs, I highly recommend that you buy one if you can afford it. If not, there are better scientific calculators that you can use online. Like Google's is a little bit better because you can type into it and it's a little easier to work with. All right. So this is $6,104.98. Just because I want you all to sort of be conscious of this, I want you to be able to say, the interest earned is $1,104.98. So that is how much interest you earn if this is compounded monthly, left alone for 5 years. I want to ask a question here, which is a question that very much feeds into something that we're going to be discussing in the next lesson. So in this example, we started out compounding monthly. What if the compounding were daily? Okay, and for yourself, like, you could explore further, like, what if it had been weekly? What if it had been quarterly? So play a little bit with the number of compoundings and see what you see. So what am I asking you here? I'm saying, what if instead of adding the interest we earned at the end of the month in and having that interest earn interest the following month, what if we did that every day? So the interest you earn every day is added, and the next day it earns interest too. So think about, do you think this is going to have a significant impact on the value of your investment? So there's a couple of things to consider. So first of all, there are roughly on average 30 days in a month. So you're compounding 30 times more frequently. Okay, so that might seem to be an argument to say, oh, it's going to make a really big difference on the amount that you're left with. But on the other hand, if you let the compounding happen once a month, you let that interest accrue for a whole month before you add it back in, and it's accruing at a much higher rate, right? Rather than accruing at a rate that is 365th of the annual rate, which is the rate you're dealing with daily, you're accumulating interest at a 12th. So some of you might say, well, you're adding it in more frequently, but you're adding in a lot less every time. So it might be kind of a wash. That would be the right line of thinking. But let's see what we end up with. So we have A. We still don't know A. P is 5,000. The only difference is that N is 365 this time. In fact, let me write a little note here. There are 365 days in a year. So N is 365. And then, of course, here, when we're talking about the total number of compounding cycles, we're no longer talking about the number of months in 5 years. We're talking about the number of days in 5 years. And since there's 365 days in a year, this is 1,825 days. So you're raising to a much, much higher power, but the number you're raising is much, much smaller. So let's see what we get. So we have 0.04 divided by 365 plus 1. We're raising that to the 1825th power, and then we're multiplying it by 5,000. So the amount that you end up with is $6,106.94. So the interest that you earn in 5 years is $1,106.94. So it's a little bit bigger, but it's not even $2. Right? So you increased the number of times that you compounded 30-fold, right? Since there are roughly 30 times more days in a year than there are months. But you only increased your interest by $2. So it doesn't seem to be a great payoff. I want to do one last thing here, just kind of to keep this on our minds. maybe I'll do this in green or something. Note, if the interest had been simple, so I'm just going to look at the interest formula. Interest is principal times rate times time, right? So in this case, that's 5,000 times 0.04 times 5. So 0.04 times 5 is 0.2. So when we multiply those, we get 1,000. So clearly, there's a significant difference between simple interest and compound. And those of you who are curious, you could explore a little bit. That's after 5 years. What if it were after 10 years, after 20 years? So compounding, really at any frequency, makes a big difference over the long term. But the frequency of compounding does not make nearly the difference as compounding alone. So in our next lesson, which we'll start in just a couple of minutes, I'm ending this one here, we're going to look at a bunch of examples. We'll take an example kind of like this one, and we'll do a bunch more. We'll ask questions that are a little bit more interesting. And then after that, we're going to finish our next lesson with something called continuous compounding. We might actually start the lesson after that. So stay tuned for more on compound interest, and I'll see you next time. Bye.